Hello and welcome to this tutorial on simplifying fractions using cancellation. This tutorial is going to specifically focus on the cancellation method, which is going to involve us splitting a fraction into the numbers that multiply together to make them and cancelling it down that way. Okay, so let's first have a look at an example of this so that we can move forwards. So let's say we've got a fraction here which is simplify 14 over 49. So what I need to do is I need to be able to think about these numbers in terms of the numbers that multiply together to make them. So I can think about 14 being 7 times 2, and I can think about 49 as being 7 times 7. Now, if you have a fraction written like this, what we can now do is we can cancel anything that appears on the top with anything that appears on the bottom. So because this has a 7 here and this has a 7 here, I can cancel both those out, and so this fraction then becomes 2 over 7. Okay, great. And that's that. Let's have a look at one more. So let's say I have another fraction here, and I'm going to simplify 32 over 48. Okay, so I can think about both of these numbers as, I can think about 32 as being 4 times 8, and I can think about 48 as being 6 times 8. So what I can do here is I can now cancel out the 8's, and I can think about this fraction as being 4 over 6. Now 4 over 6 aren't prime numbers, they still have things that can divide them, so what I can do is I can repeat this process again by thinking about of them as what numbers make them. So I'm going to think about 4 as being 2 times 2, and I'm going to think of 6 being 3 times 2. And now, because I've got a 2 on the top and a 2 on the bottom, I can cancel out those, and that's going to equal 2 over 3. Right, what I now want to do is I want to look at this method when it comes to multiplying fractions together. So let's say we've got this question here, which is simplify 7 over 9 multiplied by 3 over 14. Now, you might remember that to multiply fractions across, we just times the tops with the tops and the bottoms with the bottoms. Now, the useful thing about this cancellation method is that we can now cancel down anything that we've got here before we do the multiplications, because although 7 times 3 is a reasonable multiplication to do, 9 times 14 is a little bit more difficult, and so if we don't have to do it, it's useful for us not to. Okay, so what I want to do here is I want to think about 9 and 14 in terms of numbers that multiply together to make them. So 7 and 3 are prime numbers, so I will leave them on the top. So we've got 7 times 3. Now, I'm going to think about 9 as being 3 times 3, and I'm going to think about 14 as being 2 times 7. Now what I'm able to do is I'm able to cancel out the 7's because we've got a pair here, and I can also cancel out the 3 here and here. So if I've cancelled these out, what I'm left with on the top is 1, okay? Because that's gone, but there is still 1 there, because essentially what we're doing is we are dividing the number by the number on the bottom. So when you divide a number by itself, which in this case that's what we're doing 7 divided by 7 and 3 divided by 3, you are left with 1. So what we get here is we get a top number of 1 and a bottom number of 6. So if I wanted to simplify this fraction here, what I can do is I can write that this is 1 over 6, and the cross cancellation method gives us a way of doing this without having to use our calculator. So let's try another one. Okay, so here we go, we've got a new question, and this one is simplify 11 over 12 times 6 over 55. So remember, we can rewrite this as our tops times tops and our bottoms times bottoms. So that's going to be 6 times 11 on the top and 12 times 55 on the bottom. And now what we can do is we can start to think about these numbers expressed in different ways. So I'm going to leave the top as the 6 and the 11, and I can see that I know that 12 is 2 times 6, and I can see that 55 is 5 times 11, And now what I'm able to do is I can do some simplification to make this more straightforward. So I can do the 11s can cancel out because 11 divided by 11 is just 1. And then the 6s can cancel out because 6 divided by 6 is 1. So I've got a replacement 1 here on the top, okay? Because, well, I'll put it above both of these actually, because this 6 has now become a 1. This 11 has now become a 1. This 6 has in theory become a 1. And this 11 has become a 1. We just don't often bother writing it down. But now what we've got is we've got 1 times 1 on the top, which is just 1. And then on the bottom we've got 2 times 5, it's 10. So I know that this calculation is equal to 1 over 10. And I was able to do that nicely without having to use my calculator because of this cancelling down method. So what I'm going to do now is we're going to have a look at some of the practice questions from the website. Then we'll do some of the scenario questions by the website. And then that'll be that. Okay, so let's have a look at a practice question. Okay, I've gone to question 9 to start off with on these because actually a lot of these questions are just like the examples that we've done. So the question 9 says, a student writes 42 over 63 equals 2 over 3. Are they correct? Okay, so what I want to see here is, are they correct? So I know that I'm going to want to end up with a 2 on the top and a 3 on the bottom. So I'm going to think about 42 over 63. And then I'm going to try to think about 42 as being something times 2 and 63 as being something times 3. Okay? Now, 42 divided by 2, well, half of 42 will be 21. Okay? And then 63, actually, yep, I can see that. 63 is also 21 times 3. I can prove that here. So 3 times 1 is 3. 3 times 2 is 6. Okay, so we can do that. 42 is 21 times 2. 63 is 21 times 3. And so therefore, the 21s would cancel each other out. So that means we have shown that 42 over 63 will equal 2 over 3. Okay, great. Right, let's now jump over to the scenario questions because they'll give us something a little bit different. Okay, so let's have a look at question 2 from the scenario ones, just because they've used a different word here, which you will be familiar with, but we haven't been using it in this session so far. But it says here, a football team won 12 out of 18 games. Write the win ratio in its simplest form. Okay, so this is interesting because it's going to require us to go from the fraction form into the ratio form. And this is a skill that I've got another video on if you need to practice, so don't worry if you don't quite pick it up here. But let's go through it and see how that works out. So if I've got 12 out of 18 games, I can write that down here. So we've got here 12 out of 18. So first of all, let's simplify this fraction. So I know that both of these can be divided by 6. So I'm going to use that because I think that might be the largest number that they both divide by. So 12 can be 2 times 6, or 6 times 2. 18 can be 6 times 3. So what I see here is that I can cancel down the 6's, okay, because 6 divided by 6 is 1. So what I'm left with here is the fraction of the games that they won is 2 out of 3. So what I now need to do, they want me to write the win ratio in its simplest form. So if I've got win to lose, and I know that they've won 2 out of 3 games, what I can say here is that the win is 2 and the lose is 1, because that means that they have won 2 out of the 3 games. So here we go. That is the win ratio, well, the win to lose ratio in its simplest form. Okay, let's try another question. Okay, so here we go. We've got question 3 here, and it says, a shop sells 30 red t-shirts and 45 blue t-shirts. Express the ratio of red to blue in its simplest form. Okay, right, so because we've been learning about the simplifying fractions, I'm going to go for a fraction approach to this question first and then turn it into a ratio at the end. So what we're first of all going to do is we're going to add the 30 and the 45 together to get 75. So I know that there was 75 t-shirts sold altogether. So I can think about these fractions as being 30 out of 75 and 45 out of 75. And so these are going to be the two things that I'm looking to simplify, okay? So let's have a go at doing that. Let's do the 30 over 75 first. So 30 over 75. Right, well, I can see initially that both of these things can be divided by 5. Okay, so I'm going to think about that to start off with. Or actually, both of these things could be divided by 3. Let's go with 3. No, let's go with 5 first, because I know that 5 is really obvious. One ends in a 0, one ends in a 5. They are both divisible by 5. So I'm going to think about 30 being 6 times 5. And I'm going to think about 75 as being, well, it's 15 times 5, okay? So 15 times 5, okay? Let's now cancel what we can. So the 5s can go. And so then we're left with 6 out of 15. Now 6 out of 15 can be 2 times, well, 6 can be 2 times 3. And 15 can be 5 times 3. So we can cancel out the 3's. And this can then be written as 2/5. Okay, so we now know that 2/5 of the t-shirts are in fact red. So 2/5 are red. Actually, so I don't need to do the other half because the other bit will just give us 3/5. So if we're looking at red to blue, okay, we're going to have 2 of the reds because 2 out of 5 are red and 3 out of 5 are blue. Okay, great. Well, that takes us to the end of this topic. Now, remember, there's loads more practice that you can do over at crackmaths.co.uk. And remember, this was tutorial 73. So I hope this is useful to you and hopefully see you in another tutorial. So long.